Hello everyone. So last time we talked about finding confidence intervals in general. So in this section, we'll talk about large sample confidence interval for a population mean and proportion. Now, what do you mean by large sample? So in various book, some book use large sample means n greater than equals to. Let me use another color. N greater than equals to 40. Some other book may also write n greater than equals to 30, but I'm going to use 40 here to consider large sample. Okay, so there are two conditions. If our sigma is known, then confidence interval, we again use the same formula as before. This is x bar z alpha over 2 sigma over square root of n. Now, if our sigma is unknown, then for finding confidence interval, our formula is pretty similar. Instead of using sigma, we use sample standard deviation, where S is sample standard deviation. So for large sample, our formula is pretty same as before. Only difference is if our sigma is unknown, we use sample standard deviation instead of population standard deviation. Let's see one example. Now, a random sample of 100 lighting flashes in a certain region resulted in a sample average radar echo duration of 81 seconds. So that's our average. So x bar is 0.81 and total sample is 100. So of course this is large sample. Again, we are considering more than 40 as large sample here. So we can use these formulas now. And the sample standard deviation is 0.34. Remember the keyword here, this is sample, so we don't know the sigma, so we are going to use the second formula. So S is 0.34. So question is find 99% confidence interval. Now here, using the formula, this is x bar plus minus z alpha over 2 s over square root of n. Now x bar is 0.81. Now what about z? For 99% confidence interval, we know that if we compare this with 1 minus alpha 100% confidence interval, alpha is 0.01. So z alpha over 2, z 0.005. Now we saw that from normal table last time. So this value is approximately 2.57. Using table. So substitute that value and 0.34 divided by square root of 100. Solve this, you'll get 0.088. So therefore 99% confidence interval gives you, so first subtract these two numbers, which is 0.722, 0.898. Now interpretation is very important. So here we are 99% confident that the true average echo duration is between 0.722 second and 0.898 second. So that's the interpretation. Now this is finding confidence interval for population mean. Now let's see one example for population proportion. Proportion means just like a ratio. For example, what proportion of people in this room are boys, such kind of thing. Now if let's say proportion P and sample is N. Now if product of NP is greater than 10 and N times 1 minus P is greater than 10, if N and P meet these two conditions, then for finding confidence interval we can simply use P hat, that's sample proportion, times square root of P hat 1 minus P hat over N, where P hat is sample proportion. This P hat equals X over N. N is sample size and X is number of success, just like binomial distribution. Now note if this condition I mean NP greater than 10 and N1 minus P does not meet, use formula 7.10 from our textbook. This is a very ugly looking formula, so I'm not gonna ask you to use this formula. I'm not gonna ask problem where you need to use this formula, so just know this this confidence interval. This is similar with our previous formula. Here we replace X bar with proportion and this standard deviation by P times 1 minus P. If you remember, that's the variance for binomial distribution. Variance for binomial distribution is N times P times 1 minus P. So simply solving that for the sampling distribution, we get that result. Now let's see some examples. Now, an April 2009 survey of 2,253 American adults, so that's RN, revealed that 1262 of the respondent has had at some point used wireless means of for online access. Calculate 95% confidence for the proportion of all American adults who at the time of the survey had used wireless means for online access. So and is this we can consider that number is x. This number is the number of the respondent that had at some point used wireless means for online class access. So simply the proportion of this number is x over n 1262 divided by 2253. That's 0.56. And for 95% confidence interval z alpha over 2, remember alpha here is 5%, so it's 0.05 over 2. So just like our previous section, we know this value is 1.96. So therefore 95% confidence interval is p hat plus minus z alpha over 2 square root of p hat 1 minus p hat over n. Now we have all these values. So this is 0.56, this is 1.96, this is 0.56, 1 minus 0.56 over 2253. So solving this, you'll get plus minus 0.0205. So therefore 95% confidence interval is between 0.53 0.5395 to 0.5805. Now in this scenario, our interpretation is we are 95% confident that the proportion, remember we're talking about proportion here, that the proportion of all American adult who at the time of survey had used wireless means for online access is between 0.5395 and 0.5805. So that's the interpretation of this 95% confidence interval. Now again, just like our last section, you can also use calculators to find the confidence interval directly. Now only thing that you need to be careful about is your calculator asks for x, not p hat. Now we know p hat is x over n, so x is p hat times n. So find x and then use this value to find the required confidence interval in your TI calculator. Also write whole number for x. Now let's talk about how to calculate the required sample size for desired margin of error or width for population proportion. Now just like our previous section, we use the similar result here Now here we know confidence interval is proportion plus minus margin of error. So here margin of error, let's say this is E, and E in this case, if you look at the formula, E is this proportion. This second half is our margin of error, so we use that formula. G alpha over 2 square root of proportion minus 1 minus proportion over n. Now if you square this, that's G alpha over 2 square p hat 1 minus p hat over n. And if you solve this for n, you will get Z alpha over 2 square p hat 1 minus p hat over e square. So that's the formula we use to find the required sample size. Also note that remember our distribution. So margin of error is this distance in both sides. So if you calculate the width, this width, then we can write width sorry, let me correct the spelling. So width is 2 times E, so using that, n is, so error equals W over 2 4 Z alpha over 2 square proportion 1 minus p hat over W square. So we can use this formula also. So if you have information about margin of error, use the first one. If you have information about width, use the second one. Now quick note about p hat. Now if you know p hat, just use that value in these formulas. Now if you don't have p hat, use p hat equals 0.5. That will give you the largest possible answer for n. And if p hat is close to 1 or 0, you'll get the smaller sample size. Again, if these two condition does not meet, you need to use the long version you found in textbook. But I'll not going to ask problem where you need to use this formula. Okay, let's see example. A state legislature wishes to survey residents for her district to see what proportion of the electorate is aware of her position on education funding. What sample size is necessary if the 95% confidence interval for P is to have a margin of error, I correct that one, to have a margin of error of at most 10%. Now here error term at most 10%, so simply we can take 0.1 and p hat, since this is unknown for this first problem, we can pick 0.5, and for 95% confidence interval we can take z value is 1.96. So therefore, using the formula z alpha over 2 square p hat 1 minus p hat over e square. So we know all of these values, so if you calculate this you will get 96.04. So round up, which is equivalent to 97. So always round up your answer, because otherwise you'll not get the desired 95% confidence interval. Now if p hat equals 0.73, other values are same, so z alpha over 2 equals 1.96, e equals 0.10. so thus, using the same formula, so if you calculate this one, you will get 75.7. And remember, this gives you, if you take p hat equals 0.5, that will give you the largest n value, so we're definitely gonna get smaller n value. So if you round this off, so which is approximately 76. Okay, that's it for this section.